Hello, AP Physics 1, it's Mr. Ng. If you watched that College Board video, at least the very first one, Greg Jacob goes through a technique called factors of change. It's not a technique that I taught you guys in class, but I thought it was a very novel way to go through that kind of mathematical thinking. I know that in the past we've kind of like doubled things and halved things, and we kind of struggled with this. So maybe this technique will get us through it better. So here we have a pretty straightforward kinematics question. So we always start with VVATX, but instead of VVATX, that's all translational. Let's do omega, omega, alpha, t, theta. This is initial, this is final. And here our initial is 200 RPM. Our final is 0. Our theta, our alpha is what we want to know. There's no time. And our theta is 500 revs. Good. So we can't have time. So this has time, get out of here. This has time, get out of here. This is the equation we got to use. So this is omega final squared is equal to omega initial squared plus 2 times alpha times the change in angular displacement. Good. This is our 0. That means omega squared, omega initial squared is equal to negative 2 alpha change in displacement, right? That means that my alpha is equal to omega squared divided by negative 2 times theta. If I plug in, let's just solve this sucker. So 200 squared divided by, I could just plug it in, that'll help. 200 squared divided by negative 2 times 500, right? Divided by 1000. So it's negative 40 revs per minute a minute. Oh, that's ugly. Revs per minute. Whatever. I was too lazy to turn it into rads a second. It's fine. It's fine. It's fine. Okay, this is the most important part. This is kind of the new skill that we need to practice, which is this thing called factor of change. So the rules go like this. We start with an OG equation, or derived equation, which is alpha is equal to omega initial squared divided by negative 2 times the change in displacement, right? So this says by what factor of change will occur if the fan stops in 1,000 revs. So that means the displacement is 2 times the displacement, right? So here's the rule. For anything that doesn't change, you replace it with a 1. And then what does change, you put the actual multiple that it changes by, right? You write it. You write what does change. All right, so let's figure that out. So the alpha will change, so we're going to write alpha. The initial is not going to change, so we're going to write 1. And then the revs does change, so the negative 2 doesn't change, so that's going to be a 1. That's going to be a 1. So this is going to be 1 times, but this is 2 times bigger, so we're going to write a 2, right? So the new acceleration, then let's call this nu. The alpha nu is equal to 1/2 the original alpha. The factor change is 1 over 2, right? The new one is going to be half of the original. Good. Let's do another one. Let's do another example. Okay, again, with factor change, if it does not change, then you replace that variable or number with 1. And if it does change, then, I don't know, you write it down. Write how it changed. That's pretty good. So our derived equation was alpha is equal to omega initial squared divided by 2 times theta, and it's negative. So this is going to change, so we're going to leave that alone. But in this change, the only thing that changes is the initial angular velocity. So this is going to be replaced by a 2, right? It's 2 times bigger. The original was 200. And then now this is a 1 and this is a 1. The 2, that number doesn't change. The theta doesn't change in this question. So now my new alpha is equal to 2 squared divided by -2 theta, right? Don't forget that there was a little square here. So that means the new acceleration is, oh, this is a 1 and this is a 1. That means the new acceleration is 4 times bigger, right? 4. The new acceleration is going to be 4 times bigger. There you go, that's how you do it, right? If it does change, replace it with the number 1. If it doesn't change, replace it with what it changes by, and then just plug in and simplify your derived equation. Thank you very much for watching.